My name is John Renshaw. I'm Director of Security Research Services at NCC Group. This is Charlie Halford from the BBC. And just a quick run-through of the agenda. So I'll start by just exploring the threat from deepfake-enabled cyber attacks. Charlie will give you some information about C2PA and the content credentials standard that's developed by the C2PA, which is the Coalition for Content Provenance and Authenticity. Then, in a little bit more detail, we'll cover the conformance program. I will do a few slides on what the future of conformance looks like for products that meet the content credentials standards, and Charlie will share some of his experience in implementing C2PA within the BBC. So just diving into the threat. I'm sure you've seen online, on social media, examples of people using generative AI to create fake identity documents. So obviously there's a threat there to processes like Know Your Customer and anti-money laundering. Recently there was a news article about an Airbnb host who doctored with AI some images to make a false claim against a guest for thousands of pounds. And there's, on the dark web now, there are, a whole cottage industry of bad actors generating fake IDs. You may have also heard of deepfake-enabled attacks against businesses where attackers impersonate senior members of the organization, the executive committee, chief financial officers, and use that then to put pressure on people within the organization to make financial transactions. And unfortunately, there have been examples of this in the news where large organizations and small organizations have transferred hundreds of thousands of pounds up to millions of pounds to attacker-controlled accounts. And these attacks and scams are being enabled by deepfake technology. The AI Incident Database has published some research that shows now that deepfakes are now kind of the default model used in scams targeting consumers. So things like social media investment scams and romance fraud are all, in the majority now, being supported by deepfake technology. And also, deepfakes are being used in hiring fraud as well. So people are using deepfake technology and generative AI to gain jobs in the tech sector, and then using that access once they've been hired to either pivot further into the organization and carry out further attacks, whether that's data exfiltration, sensitive intellectual property, or even just bring in a paycheck and using, funneling that money into other criminal activities. I'm just going to play a short audio clip now.
Last year, we published research into deepfake capabilities to deliver phishing, voice phishing attacks, using identity spoofing, open source intelligence, social engineering analysis, and conversation practice. We have created a real-time voice encoder, which means our red teamers can convincingly impersonate a target. Deepfake-enabled attacks are becoming increasingly practical and will continue to improve in quality and accessibility.
So I think what's interesting about that, you may have guessed that was a deepfake of my voice, but that was trained on a normal laptop, not a big GPU cluster, on just 3 or 4 sentences taken from a recording of a presentation I delivered, which is basically a version of this talk that I delivered internally previously, and then that deepfake was created. And so you can imagine the accessibility now of deepfake technologies to attackers is becoming much more accessible. And the research then that we published last year, where we show that some of the processes that we've developed and are integrating into our assessments for customers, red team engagements, showing how we capture audio and video samples using open source intelligence. We then feed that into a model process to generate the deepfake models, and then we use social engineering specialists who kind of learn about the rhythms and the patterns in people's voices to then try and implement social engineering attacks. And this can all be done in real time now, so the person can be speaking on a call or on a teleconference with the target, and it's all being done real time, allowing them to effectively impersonate someone. Before we dive into content credentials and the C2PA organization, this is an interesting control, but there are other controls available to us. As always, good user awareness and training of the types of attacks that they might be targeted with. Thinking of your email phishing campaigns, that making users aware that they can be targeted by deepfake attacks, and putting processes and controls around your financial processes as well. There are also technological controls available. So Google have developed SynthID watermarking technology, where you can, a watermark is automatically added to generative AI outputs so that you can test. And also deepfake detection is an active area of research, but I think it's still yet to reach the level of maturity where it's really effective and with acceptable levels of false negatives and false positives. So that's just a little bit about some of the other controls available to us. Just hand it over to Charlie.
Thanks a lot. Okay, so we saw a run through of some of the other technologies that are available. So I'm going to talk a little bit about what C2PA is, but I guess one of the questions is, why do we need C2PA? So one of the things that was, I guess, top of the mind when we thought about C2PA was the ability to prove something positively. So can we absolutely say that this thing came from this specific camera, or this thing came from this specific organization? Some of those other technologies don't allow you that kind of absolutism, I guess, but the level of ability to do that is why we created C2PA. And the other reason was to provide visibility and transparency into that whole chain. So rather than just saying this is AI or not, C2PA, as you're going to see, lets us put lots of different kind of information about where that thing came from. Okay, so what is it? It's a standard, a metadata standard that allows you to digitally sign media as it is created and changed along its journey in order to get out to consumers. So inside it, we allow people to define the actions that happen on content. Did I edit it? Did I cut it? Did I clip it? And maybe add some of the important point of capture data, like what time was this taken? Where was this taken? We can add labels that tell you whether a particular thing created this with an AI model. And this is in use by some AI companies today. All of that is signed by the thing that's doing the manipulation or the creation, so the camera or the software in your organization. And optionally, we can add the signature of the creators or publishers. And then crucially, we've got links. So each time something is signed, we maintain a link and we show the provenance by being able to step through the history of how it's worked. So in this example, we just sort of stepped through maybe how this might work in reality. So right at the top of that diagram there, we've got a camera. And that camera is saying this piece of media, let's call it an image, was taken in a particular place at a particular time, and that camera itself has signed that data. So we then pass that along. Maybe somebody gets it into something like Photoshop or another image editing program. They do some filtering on it. Maybe they change some colors. Those actions are then captured in that C2PA data, and again, that's then signed. So the edit suite or the edit program in this situation signs it. And then in this third layer, we're saying, okay, maybe that's come out of the editing program, and maybe a broadcaster or a newspaper or somebody wants to publish that for their users. So maybe they compress that so that it's available on their website. They might add a caption or some other interesting data. And again, they then add a signature to it. So in this case, a news broadcaster. So all of that can be captured inside the content's metadata. And then the key bit is that when a consumer or anybody wants to look at that, they can verify that those steps have happened and that the people involved have actually signed them. So just briefly, this is what the file structure looks like. So inside each image, video, audio file, document, we embed this data structure. So we have the claim signature, the signature itself. It uses regular X509 certificates and private keys. That hashes and signs what we call a claim. The claim contains a hashed list of assertions. Assertions are the bits of metadata you care about, the actions, the location, the time. And then there's a key final assertion, which is the hashed link back to the bits of the date of the image, video, or audio file, so that you can't manipulate that file without being detected. So what does it look like? So on the left here, we've got, I think this is Instagram, so where C2PA is used in a AI detection capability, so where somebody's looking at the C2PA signature and they want to see, was this AI generated? There's a piece of metadata in there that tells them. Instagram showed this AI info for a while. On the right here, we've got the C2PA's website, where they've got a built-in verifier that shows you a lot more detail. And then this is an example of LinkedIn. So LinkedIn supports C2PA, and in this situation, this is the BBC's content, and it says signed by the BBC, and the point and the time it was signed. So then, briefly, how do we trust this stuff? So we talked about the hashing mechanisms and how we bind it to the content, but what about the who, the signer? So we have credential issuers, they're certificate authorities in our world, and they issue certificates to signers when they can identify them. So they attest to the identity of the signer. The validators, the bits of functionality you might see in LinkedIn or in those other pictures, that has a list of certificate authorities it trusts to make identity, to validate the identity of the signer. And then finally, the consumer trusts the validator to do its job and to identify signers, but it also the consumer is the one that makes a decision as to whether they should trust the signer. And so that decision that the consumer makes, should I trust this signer, should I trust who said this thing, has sort of led to something that we call the Conformance Program, to put some underlying requirements in place so that the consumer can rely on the signer having adhered to some base level of security in order to do its work, so that there's a layer of trust in there. And how that works is in the C2PA organization, there's something called the task force, the Conformance Taskforce, that creates these security requirements, generator product security requirements. And then products who want to create C2PA signatures, so cameras, editing software, publication software, then applies to the C2PA conformance program. They submit some evidence that shows how they meet those requirements. There's a group that decides whether they have met them, and if you do, you get onto something called the conforming products list. That conforming products list is then the gateway to getting a certificate. So then you are able to go to a certificate authority and say, hey, I'm on the list, can you grant me a certificate? Those requirements broadly spread across 2 assurance levels at the moment, as well as a base level. So the base level is you must implement the specification correctly, you must do validation correctly, all of those kind of things, some compatibility testing, and the requirement that you produce accurate manifests. And then you've got the security requirements on top. So at level 1, we need to make sure that our private key is encrypted at rest. We need to make sure we're doing vulnerability scanning, and we need to make sure that our patches are applied within a certain amount of time. And then we apply some other basic security measures, such as TLS, if you've got a distributed architecture between the components, and patching. At level 2, that's ramped up a bit. We then require that both the binaries that are running are attested to by some platform that they run in, and that those attestations are used by the certificate authority to issue certificates. And then we also require that the private keys in the situation are inside a hardware security module as well. Extra requirements on exploit countermeasures. We require some static analysis and patch recency, and then a load of other hosting security requirements around audit logging and intrusion detection. And then finally, those conformance requirements talk a lot about the device. So what device, what software signed this? Was it an editing software? Was it a camera? Was it a publication software? But then the next level is we can bring in publisher and creator signatures as well. So the standard allows for this, for extra bits of data to be added to it. And there's what we call a sibling standard called CAWG or CORG, and that allows you to sign with an organization certificate. So you can say this thing came from the BBC, and we care about these particular assertions.
Thank you. Right, I'll just do a brief overview of the potential future of where C2PA and the content credentials is going. So currently there are 50 different products on the assured products list, and you can view them yourself on the C2PA website, as well as a number of different certificate authorities. In terms of the cybersecurity controls that content credentials gives you, Charlie's already mentioned that there's signing and hashing, so the metadata is tamper-proof, and there are security requirements around protecting the private key so that you can't forge someone's digital signature. You can also add timestamps. There are weaknesses, though. It's not a silver bullet, so it is metadata, so it's optional to add this data, and that there's an element of by design for that to enable organizations to perhaps adopt their own private standards as well. Metadata can be removed. Actors could add the CR logo, the content credentials logo, to pretend like it's digitally signed. And with any technology, there will be vulnerabilities, and the key is how we respond to those vulnerabilities to maintain trust in the ecosystem. So what's next? Well, could we see content credentials start to be built into some of the technology that they use that are vulnerable to deepfakes? So things like teleconference calls, webcams, integrated into processes like Know Your Customer and anti-money laundering and evidence gathering for insurance claims. Events like this to raise awareness amongst consumers so they know what content credentials is and what it provides them, and potential for higher levels of security. So currently we've got 2. Could we develop more stringent security requirements for those really high-level use cases, things that are involved in legal processes or really professional media? And there's more info, and the security requirements are available online. Charlie's just going to finish with a little bit of experience.
Thank you. Yes, so the BBC has done some work here. So we created a trial with about 5 bits of content on BBC News, where we included some manual verification checks in the set of metadata that we provided to people. And we asked people at the end, if we give you this extra data, does it help you, does it increase the trust in the content? And we got about 80% of people in that trial saying yes. So that was our question of, is this going to be helpful? So we think the answer to that is yes. The next thing we've done is we've started to take media coming into the BBC and running it through a C2PA validator. And if it's got that C2PA data in it, it's going to tell us a few things. If it's AI generated or not. Potentially if it's come from a camera that supports C2PA, that can tell us whether it's potentially genuine as well. So some of those cameras are the Sony Alpha range and the Google Pixel phones from 9 and 10, I think. But we're expecting more. Then we also did this in partnership with Sony, so demonstrating what video might look like. So you can see we've got a real life capture there where the Sony camera is used. This bit is not using that signed camera, so we get this kind of question mark. And then we skip forward again, so this is using the signed camera, and then suddenly we switch to AI, and we can get that AI label through as well. So all of this is captured in the C2PA data, and it's just how we show to users that we were already testing there. And then the next thing we've got coming up is we're working on a trial with LinkedIn to get more of our content onto LinkedIn with that BBC signature. And we hope more to come. And then just very quickly, the number one thing to talk about here on the left is risks around privacy. So having all this extra metadata, if you've got a situation where that metadata might hurt somebody in the field, the person who's taking it, like the location or the date and time, the redaction feature of C2PA is useful, but we need to make more use of it. And then on the right-hand side, one of the open questions is AI materiality. If we're going to signal this is AI generated, how much of something needs to be AI generated before we apply the label? Thank you very much.